In this video, we're going to focus on properties of exponents. So let's say if we want to multiply x squared times x cubed. Whenever you multiply common bases, you need to add the exponents. 2 plus 3 is 5, so it's x to the 5th power. This is known as the product rule. Now, what if we have x to the 7 divided by x squared? If you're dividing, you need to subtract the exponents. 7 minus 2 is 5. This is known as the quotient rule. And what about x cubed raised to the 5th power? When you raise one exponent to another power, you need to multiply. 3 times 5 is 15. And so that's known as the power rule. And anything raised to the 0 power is 1. Now let's understand some of these. Let's go back to the first one. So why is x squared times x cubed equal to x to the 5th? Well, we need to know that x squared really represents x times x. You're multiplying two x's together. X cubed is x times x times x. In total, we have 5 x variables being multiplied together. So it's x to the 5th power. Now what about that second example? X to the 7 divided by x squared. Why is that x to the 5th? X to the 7 is equivalent to multiplying 7 x's together. X squared is just x times x. X divided by x is 1. So we can cancel 2 x's on both sides, leaving behind 5 x variables, so that's equal to x to the 5th. Now what about this one? What's x squared raised to the 3rd power? According to the power rule, when you raise one exponent to another, you need to multiply. 2 times 3 is 6. Now to understand it, x squared raised to the 3rd power means that we have 3 x squares together. And each x squared is x times x. So notice that we have a total of 6 x variables multiplied to each other. So that's why it's x to the 6. Now let's work on some examples. Try these problems. Simplify the expression y to the 4th times y to the 7th, and also 3x squared y cubed times 5x to the 4th y to the 5th power, x to the 9 divided by x cubed, and also this one as well, 36 x to the 7 divided by 9x to the 4th. So feel free to pause the video and work on these examples. So let's start with the first one. 4 plus 7 is 11. So the answer is just y raised to the 11th power. Now for the second one, the first thing you want to do is multiply 3 and 5. 3 times 5 is 15. Next, multiply the x variables. X squared times x to the 4th. They're common bases, so we can add the exponents. 2 plus 4 is 6. So it's x to the 6. And then y cubed times y to the 5th power is y to the 8th power. So that's the answer. 15x to the 6, y to the 8th. Now for the next example, x to the 9th divided by x to the 3rd, you need to subtract. 9 minus 3 is 6. So you're going to get x to the 6th power. Now for the last example, divide. 36 divided by 9 is 4. Now x to the 7 divided by x to the 4th, we need to subtract the exponents. 7 minus 4 is 3. So we're going to get 4x cubed. Let's try some more examples. X to the 4th raised to the 5th power, 2 to the 3rd raised to the 2nd power, and also 3x to the 4th raised to the 5th power. I mean, not to the 5th, but to the 3rd power. And also 2x squared raised to the 4th times 3x to the 5th power squared. Try those. So looking at the first one, whenever you raise one exponent to another, you need to multiply. 4 times 5 is 20. So it's x raised to the 20th power. Now for the next one, we can multiply the two exponents. 3 times 2 is 6. But figuring out 2 to the 6th, that's going to take some time. Instead, let's find a value of 2 to the third power. 2 times 2 times 2, 3 times is 8. So 2 to the third is 8. So we have 8 squared, which is 8 times 8. That's 64. So that's the answer for the second one. Now for the third one, we need to find out what 3 to the third power is. There's a 1 right now. So if we multiply 1 and 3, we're going to get 3. So we have 3 to the third times 4 times 3 is 12. So it's going to be x to the 12th. Now 3 cubed, 3 times 3 times 3, 3 times is 27. So the final answer is 27 x to the 12th power. Now for the next example, let's distribute the exponents. That is the 4 and the 2. 1 times 4 is 4. And then 2 times 4 is 8. And then this is multiplied to 3x to the 5th squared. 1 times 2 is 2. So we have 3 squared. 2 times 5 is 10. So x to the 10. Now let's multiply. 2 to the 4th is basically 16. 3 squared is 9. 16 times 9 is 144. Next, let's multiply x to the 8 times x to the 10. So we got to add 8 plus 10. 8 plus 10 is 18. So we're going to get x to the 18th power. And this is the final answer. Now we still have a few more problems to go over. Let's try 4x cubed y to the 5th power divided by 3xy squared, all raised to the 3rd power. So try that one, and also try this one too. 5xy divided by 2x cubed y to the 4th raised to the 0 power, and also negative 2 xy squared raised to the 0 power. So let's start with the first one. You can combine the exponents, or you can divide first. In this case, let's distribute the exponents first. So all the exponents we're going to multiply by 3. So 1 times 3 is 3, 3 times 3 is 9, 5 times 3 is 15, 1 times 3 is 3, same thing for the other one, and 2 times 3 is 6. Now 4 to the 3rd power, 4 times 4 times 4 is 64. 3 to the 3rd power, 3 times 3 times 3 is 27. Next, let's divide. X to the 9th divided by x cubed. So we got to subtract the exponents. 9 minus 3 is 6. So this is going to be x raised to the 6th power. And now for the y variables. 15 minus 6 is 9. So this is going to be y to the 9th power. Now for the next one, anything raised to the 0 power is simply equal to 1. That's it. So therefore, xy squared raised to the 0 power is 1. The negative 2 is not affected by the exponent, so the negative 2 will remain. So this is going to be negative 2 times 1, which will give us the final answer of negative 2. So those are just a few examples of properties of exponents. Make sure you understand this. Now let's talk about negative exponents. What is x to the negative 2? How would you simplify that? How can you make the negative exponent positive? Typically, whenever you want to simplify the expression, you want to get rid of all negative exponents. You want to make sure all exponents are positive. All you need to do is change the position of x. If it's on the top, move it to the bottom. As you change the position, the sign is going to change. It's going to change from negative 2 to positive 2. So let's say if we have 1 over x to the minus 3. If we move x from the bottom to the top, the sign is going to change. Instead of being negative 3, it's going to be positive 3. So let's say if we have 3 over 4 raised to the negative 2. If we simply flip the fraction, if we move the 3 to the bottom, the 4 to the top, the exponent will change sign. It's going to be positive 2. And now we can square each number. 4 squared, which is 4 times 4, that's 16. 3 squared, 3 times 3 is 9. So the answer is 16 over 9. So likewise, let's say if we have x cubed raised to the negative 4. First, we can multiply 3 times negative 4, which is negative 12. And then we can make the negative exponent positive by moving x to the bottom. So it's 1 over x to the positive 12. And that's just a basic introduction of negative exponents.